Okay, so in this 2D motion review question, we're looking at in the context of American football. There's a quarterback, it's throwing two different types of passes: a lob pass indicated by curve 1, and then a bullet pass indicated by curve 2. But the problem is referring to the lob pass, that's curve 1. So we know that the lob pass is thrown at an initial speed of this, and we know the time of flight is 2.5 seconds, and they're looking for the launch angle. Now, to find the launch angle, you would typically need the initial x velocity and the initial y velocity, or the actual velocity itself. So, or basically two of those pieces of information. So if I draw a quick picture here, it's some sort of non-zero launch angle. We know the hypotenuse. We know that this is 18.6 meters per second. So to find the angle theta, we either need to find the initial y velocity or the initial x velocity. And then once we have those, we could use either sine inverse for VIY or the cosine inverse for VIX. So I'll do sort of both methods. I'll do the easier method first, so we can try to solve for VIX. Because we know the x distance and this displacement, and then we know the time of flight. So this one, I know that Vx is constant, so it's just equal to delta x over delta t. So then Vx would just be equal to 35 meters divided by the 2.5 seconds, and this gives you 14 meters per second. So then we can find the theta using the cosine inverse of the VIX, which is 14 over the hypotenuse, 18.6, and gives you 41.2 degrees. That would be choice C. And there's also enough information given in the y direction to also solve for VIY. It's a couple of extra steps, but it's possible. And in this particular case, we can think of the equation delta y equals VIY delta t minus 1/2 g delta t squared. But for this pass, it's launched and falls at the same height it's launched. So there's 0 delta y. So if I think about VIY delta t would then be equal to 1/2 g delta t squared. I can cancel that square up there with one of these delta t's on the left. So VIY would be equal to g delta t divided by 2. And if you substitute 9.8 meters per second squared for g, 2.5 seconds for the time of flight for delta t divided by 2, initial y velocity is 12.3 meters per second. And then finally the theta in this case would be the sine inverse of 12.3 meters per second over the initial speed, and that would give you again the same answer. So either method will work fine. I'm thinking the initial solving for VIX would be the simpler of the two.